Unraveling the impact of sleep deprivation and mistimed meals on circadian rhythms of BTBR mice. So imagine your body as this well-orchestrated symphony with each instrument playing in perfect harmony. So in our bodies, this harmony is governed by something called circadian rhythms, which act like the conductor of the orchestra, guiding our sleep, metabolism, and overall health in this synchronized dance with the natural light-dark cycle of the day. So you can think of this as the mediator between our external and internal environments. As you can assume, circadian rhythms are vital for our well-being because when they're disrupted, it's like the orchestra losing its conductor. Everything just starts falling out of tune. Disrupted rhythms have been linked to a host of health problems, from sleep disorders and mood disturbances to more severe conditions like diabetes and heart disease. While we often associate circadian rhythms with sunlight or light, it's been discovered that our lifestyles can also act as powerful cues, influencing our internal clocks. So this insight is crucial because it means our lifestyle choices can impact this delicate balance. So for an example, mistimed meals or sleep deprivation, it's not just about what you eat, but also when you eat. And similarly, the amount and quality of our sleep can play a significant role to our circadian rhythms. To understand these complex processes, scientists turn to animal models like mice that have similar biological systems to ours. So one group of mice is called the C57 mice, which is a standard model for studying circadian rhythms, which is often used as a control. Another special group of mice called the BTBR mice have unique characteristics like an abnormal circadian clock and metabolic abnormalities. This provides scientists with valuable clues about how our internal clocks may function. So putting this all together, this leads to my research question of what are the effects of non-photic cues, specifically refeeding and sleep deprivation, on circadian rhythms in BTBR and C57 mice. I hypothesize that BTBR mice will demonstrate different circadian responses to these cues compared to C57 mice. And so the goal is to measure and analyze the circadian phase shifts in response to these cues in BTBR and C57 mice. To do this, I will work with 12 C57 and 12 BTBR mice. And first, I will observe their natural circadian rhythms for 3 weeks in constant darkness while they have access to running wheels. This helps establish their normal patterns without any external cues or influences. And to study the effects of sleep deprivation, the mice will be awakened 6 hours before their usual wake-up time and kept active for 3 hours. After this, they will be undisturbed for a week, allowing me the time to measure the changes in their routines. For the refeeding experiment, the mice will be fasted for 18 hours starting from when they first wake up. They will then be given food back after the fast 6 hours before they usually wake up. And this change will be observed, and the shifts in their daily patterns will be noted. And finally, I will use statistical analyses to examine the results of both experiments. This will help understand how these changes affect the mice's internal clocks and behaviors. When it comes to sleep deprivation, I predict that large differences might indicate more sensitivity to sleep deprivation due to their abnormal clock, while smaller shifts might suggest that, despite their weird rhythms, they might have an alternative mechanism that helps them adapt. As well, given their unique metabolic sensitivities, big shifts in refeeding might indicate food as the cause, while smaller shifts will suggest the shift is due to the alertness associated with eating. The future of circadian research holds immense promise. As our understanding deepens, interventions derived from this knowledge could transform healthcare, improve quality of life, and mitigate adverse effects of our modern, fast-paced lifestyle. By embracing these complexities of circadian regulation, we are on the brink of a transformative era where optimizing our internal clocks might unlock a healthier and more harmonious existence for everyone. Thank you so much for watching.